Artificial intelligence. Everyone thinks AI is the future. But what exactly is AI? I think AI can best be described as learning computers solve problems which previously only humans could solve. I don't know of any other technology that will either make Earth a living hell, being subjected as slaves to our demon overlords, or make Earth a living utopia. Recently, there is this huge hype around ChatGPT. Not a day goes by where I don't see a news article talking about ChatGPT like it's the first algorithm that's ever been invented. And while the media is predicting the end of many jobs, YouTubers are way more optimistic, because with all the ad revenue they get from creating these videos about wordless trading bots that ChatGPT created, they don't even need a job in the future. It seems like AI is a recent invention, but throughout history, humans have always been fascinated by artificially created intelligence. For example, in Greek mythology, there was Talos, a giant constructed from bronze, who would run around the island of Crete 3 times a day, and he would just throw boulders at pirates trying to invade. Also, stories like Frankenstein clearly indicate that humans were really fascinated by artificially created intelligence. It would take until the invention of the computer by Alan Turing before we could finally create AI ourselves, but instead of a parade he got a chemical castration, because back then being gay was a worse sin than being Satan himself. In recent years there has been this huge surge of interest in AI. It's getting better at this at a wide variety of games, such as chess and Go. It's recommending us videos on TikTok, recommending us products on Amazon, generating images, and even coding itself. Seriously, for all this hype around transformer models, it's mostly about generating images or generating stories, but I think currently transformers have the biggest impact on how coding is done. For example, you have this thing called GitHub Copilot. You can just write in natural language what you want the program to do, and it will just generate the code for you. If you're in a computer science program, you can just easily use this to complete homework, and if you encounter any bugs, just paste the code in ChatGPT and ask it to fix it, and it works. One of the top engineers in the world, Andreas, who was previously the director of AI at Tesla, also recently said on Twitter that around 80% of his code is generated by GitHub Copilot, which is truly insane. Another use case for AI was seemingly supposed to come out just a few years ago.
A Tesla car next year will probably be 90% capable of autopilot. So 90% of your miles could be on auto.
We're probably only a month away from having autonomous driving. Like a Model S and Model X at this point can drive autonomously with greater safety than a person.
I feel very confident predicting autonomous robotaxis for Tesla next year.
I'm extremely confident of achieving full autonomy and releasing it to the Tesla customer base next year.
When do you think Tesla will solve level 4 FSD?
I mean, it's looking quite likely that it will be next year.
Full self-driving cars will truly be a milestone for humankind, by finally allowing us to go to the pub, drinking hard, and letting the car drive ourselves home instead of calling an Uber. But why is it taking so long for these self-driving cars to come out? I think even though the Tesla full self-driving beta is getting better, there are some situations on the road which would even confuse the best driver. Like seriously, what should you do in this situation? But how hard is it to create such a self-driving car, really? Well, the only way to find out is by creating one ourselves. That's what me and a friend decided to find out, by creating a new kind of algorithm so we can compete with Tesla to create a self-driving car. We have the most ultra mega exclusive algorithm that you've ever laid your eyes on. Probably even when Elon Musk is watching this video, he thinks like, damn, I wish I had that algorithm and I should hire these boys. But before I explain our hyper-exclusive algorithm, I will first give an introduction to the main concepts that are currently being used to create autonomous vehicles. First off, a camera is used for the car to perceive its environment. Also, a radar or LiDAR scanner is used for situations such as extreme weather where the camera is useless. A LiDAR scanner is better, but also more expensive and also uglier, which is why Elon Musk doesn't want to use them in Teslas. Without this perception data, we need to employ a deep learning algorithm in order to recognize the objects and also calculate the position of the objects. When this is done, we use another deep learning algorithm to get probabilities of the different types of movements that these objects can do or have. And finally, a third deep learning algorithm called deep reinforcement learning is used for the car to get the best, the most optimal type of sequence of movements to get from point A to point B. For this, they take into account different objects on the road and the different probabilities of movements that these objects have. This deep reinforcement learning algorithm is also used by Google DeepMind to learn computers to play arcade games. As you can see, these algorithms really rely on deep learning. Deep learning has the advantage that we don't need to specify ourselves what kind of features the algorithm has to pay attention on to make its predictions. It figures out those features itself. For example, to detect objects, it's really hard to define in clear rules what a certain object is. For example, when you want to detect cars, you can specify, or you might think you can specify, like a car has 4 wheels and has a rectangular chassis and has a windscreen, but we as humans, we still recognize this as a car, and this, and even this. Clearly, some kind of generalization is necessary, which is where these algorithms, these deep learning algorithms are really good at. The downside is that they require a lot of training data, and the training data often needs to be labeled for it to work. We also don't really know what kind of features they're paying attention on. The algorithm is kind of a black box. We just throw in an image and we get a prediction back. But it would be really inefficient to find out how to drive on the road if we had to just find it out by training data. If we just had to bump into objects, or find out by training data that you shouldn't drive when your neighbor is in front of you. Because we can clearly specify the traffic rules. So ideally, our AI has 2 systems. One for fast, unconscious reasoning, which is used for object detection, and one for a more structured reasoning to specify the traffic rules in. This is why for our algorithm we use NeuroSymbolic AI, which integrates deep learning with symbolic reasoning. This allows us to use neural networks for object recognition and recognition of behavior of other vehicles, while allowing us to easily specify the traffic rules in logic. NeuroSymbolic AI has been shown to outperform deep learning methods on an image and video answering task, while requiring as little as 1/10 of the training data. It truly seems like a promising approach. Because it would be very expensive to let my car drive around to test the self-driving capabilities of our algorithm, we needed some kind of simulation environment, and we have chosen GTA San Andreas. You might be wondering why GTA San Andreas, why not use GTA 5 or use the Carla environment, which is specifically developed for developing self-driving cars. Well, first off, my PC looks like this, and also because GTA San Andreas is just a really good game. It has an amazing atmosphere, good side missions, and hilarious characters.
I'll have 2 number 9s, a number 9 large, a number 6 with extra dip, a number 7, 2 number 45s, 1 with cheese, and a large soda.
I truly think it really holds up well after 20 years. But before I show you our self-driving car driving around in Los Santos, I will first explain the basics of NeuroSymbolic AI, so that the next time you're going out and going to the club and you see a cute girl, you can go up to her and talk about something really interesting. Let me know down in the comments if you found your future wife with this method. As I said before, NeuroSymbolic AI consists of deep learning combined with symbolic reasoning. And a popular method of symbolic reasoning is with predicate logic. This is a language invented by mathematicians to really easily specify the meaning of a sentence, such that every sentence has only a single truth value. We can't specify rules, or at least it's very hard to do it in natural language, because natural language, such as English, is very ambiguous. For example, consider the sentence, John hit the kid with a pair of binoculars. This could either mean that John used a pair of binoculars as a weapon and hit the kid with it, or that the kid was wearing a pair of binoculars while John hit him. Either way, John should be in jail, but at least with predicate logic we can specify the meaning of the sentence. Consider the following predicate logic sentence. It means that everyone who is subscribed to me is a chat. You can find out the meaning of the sentence by replacing the X with every possible value of the domain. And the domain is in this case everyone who is on YouTube. And then you have to make sure that the rule holds that everyone who is subscribed to me is indeed a chat, but I suppose that is true. You can see if you are good with logic and you can write down these rules, it provides a really easy method to specify the traffic rules, which is exactly the way we did it. For example, you can say that if you're in front of a tree, then the car should brake. As you can see, this is really efficient, and it's better than to specify these rules this way than that the car has to find it out by training with a deep learning algorithm, because we can just simply specify the rules this way. NeuroSymbolic AI also makes use of deep learning, and deep learning is done by neural networks, which are able to learn to classify images when given enough training data. For example, a simple example would be if you want to automate your Tinder experience. So you want a computer program to be able to decide whether you would find the women attractive or not. To do this, you would first need to gather a data set of images of women, which you would then need to annotate with whether you would find them attractive or not. Then we could use a neural network, for example, to illustrate it, a perceptron, which is a really easy form of a neural network, to learn the relation between the images of the women and the labels of attractive or not that you provided. The way the network makes predictions is by giving them as input a vectorized form of the image, which is basically a list of numbers which, for example, could represent the black or white values of the image. You would give this vector to the neural network, and the neural network would then multiply this vector with another vector which is called the weights of the neural network. This will result in a single number, and this number is then passed through an activation function which gives back a probability that the network thinks that the woman is attractive or not. Well, at the beginning these predictions are random because we have initialized the weights of the neural network also random. So in order to get better predictions, we need to train the neural network. And this is done by defining a loss function, which is basically a number that defines how bad that the network is at predicting images. A high number means that the network is really bad at predicting. So all we need to do is to adjust the weights in the direction that is the negative of the derivative of the loss function with respect to these weights. By doing that, and by doing it over lots of iterations with training data, we can finally learn how to recognize objects. I hope you now understand why NeuroSymbolic AI might be useful for developing a self-driving car, but we had to decide what language would be suitable for implementing our algorithm. Well, what we decided to use was DeepProbLog, which is probably the most exclusive language known to man. It's only, I think, known by professors at the KU Leuven University, and I think you can only find instructions for this at AI conferences when you talk to them, because there's like no thread on Stack Overflow. And I think by just mentioning it in my YouTube video, they might suspect me for being a spy from a rival university and might lock me up in their secret basement, forcing me to solve the halting problem or something. I don't know. DeepProbLog is itself an extension to prolog with neural nets. And prolog itself is an extension to prolog. And prolog is at least famous enough to have its own Wikipedia page, and it has some Stack Overflow answers. So prolog is basically used to specify these logic rules as I explained before. Consider this simple prolog program. It consists of one rule, which consists of a head and a body, and a fact. The rule means that if you're subscribed to me, then you're a chat, and the fact basically says that Tom is subscribed to me. So now we can use this program to reason about certain queries or questions we might have. For example, we might be wondering, is Tom indeed a chat? So we can answer this with the prolog program as follows. First, the program searches the head of a rule which matches with the predicate from the query. For example, in this sentence, chat Tom is matched with the chat x from the first rule. Then the x is instantiated with the variable from the query, which is in this case Tom. Then prolog is trying to match the body of the rule with the head of another rule or a fact. And this time we can match with the fact, which is that Tom is indeed subscribed to me. So now we can conclude that Tom is indeed a chat because we have concluded with a fact, and a fact is considered true. But a lot of randomness exists in the world and in traffic, and with prolog we can only specify rules which are always true. So what we need is prolog, and with prolog we can, for example, model a dice by specifying the probabilities that a fact is true. This way we can model probabilistic knowledge, and what then DeepProbLog does is DeepProbLog allows us to have these probabilities be generated by a neural network. This is even better because now we don't have to specify these probabilities up front, but instead we can have a neural network reason about the input and then generate a probability. So finally, I have explained DeepProbLog. If you have a background in probabilistic reasoning, logic, programming and neural networks, you can now finally combine them in a very unknown arcane programming language called DeepProbLog. As you can probably guess, programming in DeepProbLog is pretty hard, so you want to do at least make a simple self-driving car which would stay on the road, drive at a decent speed, and that it wouldn't crash into any objects. We specified this with the following DeepProbLog program. We have three facts. One is the lane, one is the speed, and one is the obstacle. And we have also three neural networks. The output of the lane fact is basically the probability that the car is on the left, middle, or right side of the road. The output of the speed fact is that the speed is either slow, medium, or fast, and probabilities of those. And the output of the obstacle predicate is probabilities that there is either a no obstacle or an obstacle. So what this basically allows us to do is give us some base facts about what is true with a given probability. Well, now that we have some probabilities for all the facts, we can define some rules which specify how our car needs to behave in traffic and how it needs to drive. So at first we specify that if the car is on the left side of the road, then it needs to go, it needs to press the D button to go right. When the car is on the right side of the road, it needs to press the A button to go left. When there is no obstacle and the car is not going fast, we can accelerate with the W button. When there is an obstacle, we of course need to decelerate by pressing the S button. And when the car is on the middle of the road and the speed is fast and there is no obstacle, we need to slow down a bit, so we press no key at all. So this basically are some rules specifying the basic movement of the car. Because sometimes to drive well, we need to press two key presses at the same time. We also need some rules mapping these key presses to a driving direction, which is basically a number between 0 and 8, and this number represents the two keys that are being pressed at the same time. For example, if we are driving slow on the left side of the road, we need to accelerate and go to the right. Finally, we have a driving input rule, which basically is a mapping to a driving direction. So now, how does our algorithm work? We get into a car in GTA San Andreas, we go into first person mode and then have a Python script taking screenshots of this first person view and a picture of the speedometer, which we had to mod in. Then, using this picture of the dashboard and a picture of the speedometer, we create the driving input query, which we can fill in the picture variable with the picture of the dashboard and the speedometer variable with the picture from the speedometer. And then we can ask the DeepProbLog program to generate probabilities for the different inputs, which were these numbers between 0 and 8. And then we can simply pick the number which gets the highest probability from the DeepProbLog program, and that's the number of the key combination that's going to be pressed in game. And this way we can let our DeepProbLog program control our GTA San Andreas car. So this is basically our whole program, which isn't very large and also very readable, which is one of the big advantages of using NeuroSymbolic AI in my opinion. But before our car could drive around in Los Santos, we first needed to train these neural networks. Because without training, these neural predicates don't know if the car is on the left or right side of the road, if there's an object in front of us, or how fast we are driving. But also a problem with NeuroSymbolic AI is that we can't just drive around in Los Santos in the most ridiculous way, driving over civilians, bumping into cars, because we need to drive according to the rules we have specified in our program, which is also one of the downsides of NeuroSymbolic AI, because else the neural networks will get confused. So what we did was we developed a Python program which recorded our key presses together with a screenshot of the first person view of the car. So for a lot of time, maybe 3 days, we drove around in Los Santos, just driving around, recording our key presses, which gets really annoying after a while, because driving around according to the rules of traffic isn't fun, and often the traffic of GTA is so insane, like these NPCs, they just can't drive. So we drank a lot of coffee and listened to some tunes of K-Rose.
Barefoot and pregnant again, just like my daddy, K-Rose.
And finally, after lots of driving around, we gathered enough training data to train our DeepProbLog program. So after all this of gathering of training data, training the model, it was finally a chance to see how well our model actually performs by letting it drive around by itself in GTA San Andreas. We first off decided to disable the traffic, so it would be more easier for the model to actually just focus on staying on the road and driving at a decent speed. So here it actually is, driving around. It's kind of staying on the road. We thought, okay, like it at least has some kind of lane detection. It wasn't going very fast, but okay, that's not much of a problem. But then this happens, and for some reason it drives off-road, thinks it's a boat, and goes straight into the water, something that we've never done while training. Okay, like here again, we're just driving on the road. It's kind of taking turns. We think, okay, it's working, it has some success, and then it just drives off, smashes into a wall. So in conclusion, this first model, it can stay on the road a bit for at least a while, but it's driving really slow, and it kind of is also zigzagging from the left to the right. It's a bit like a demented person driving around who forgot to take his medication. So it's not ideal, and we thought we could do better when giving the model a lot more training data, which is exactly what we did. But at least it was doing something. It was driving forward and had a bit of lane detection. Okay, so we went on to gather some more training data and trained our model for the second time, this time on more data, and we also fixed it that it should press the keys a bit longer, so to gather a bit more speed. As we can see, it's driving a lot faster now, which is better. It's also way better at following the road, so the lane detection is better. This is actually looking really promising, I think. Sometimes, however, it was turning way too slow, and that is something that we needed to fix, but it would correct itself a bit and keep driving on the lane. Like, this seemed a lot more like how the cars of GTA itself drive. We were especially proud of that it was actually capable of taking turns at a really high speed. All in all, I think this was a huge step up from our first model, and we thought we could do just a little bit better with some more training data. Okay, so here are the results. As you can see, it's driving a lot better. We just let it drive around a tour around the highway, and we're kind of measuring how many manual interventions would be necessary to let the car drive a tour. And we were really impressed. Although it was zigzagging a lot and it seemed more the driving style of a carnival ride than what we expect for a real car, it was pretty good and it could take turns. Sometimes it would get a bit off the road if the turn was too steep, and I think the results are pretty impressive. It is capable of managing to make most turns. Sometimes it does go off-road if the turn is too hard, but at least it's driving at a constant speed. It's always, most of the time, staying on the road. Actually, like with the Tesla self-driving beta, you also need to have some manual interventions. I also really think it's impressive that the model is only 1.2 gigabytes and is still managing to drive this well. So overall, we were pretty impressed with the results. And at some points it would get really fast, so I think it's not driving that much worse than most traffic in GTA, and I think it would be pretty amazing if there would actually be a self-driving car in GTA. You would just step in and have them drive for you. Even though it would just maybe crash into some objects, it would be a fun experience, I think. So now it was time for our final test. We would turn on traffic and see how well our model performs. Something about GTA traffic you should know is that it's pretty crazy, so the results should be amazing. Okay, here it is. It's just driving a lot more slower, which is to be expected because a lot of objects are around. It's following this car, but then suddenly another car comes from its left and it just drives into it. It's then still another car drives into it. Our car here correctly stops for this vehicle, which is pretty impressive, I think. As I said, the traffic is ridiculous. So we thought our car was working pretty well, but then it just drives straight into another car waiting for a red light. Here's another crazy situation. Some car bumps into a police car, which in GTA is punishable with a death sentence. The police just starts blasting at the other car. Meanwhile, our car is taking keeping a safe distance from all the violence, like we would want if we would be in the car at that moment. The police managed to kill the civilian. Okay, good job, the police think. So they drive further to kill some more people, I suppose. Our car is looking at when the road is safe, and finally, when the road is finally cleared again, civilian is dead. Instead of helping him or calling an ambulance, we just drive past it, just like it would be normal in GTA. And here, once again, our car is driving safely on the road, but suddenly a civilian with a death wish steps on the road, our car stops, and it just drives forward. So, all in all, I think our car can really handle well the ridiculous traffic of GTA. I think it's successful at that, at least being as ridiculous as the GTA traffic, is capable of driving at a decent speed, taking turns. So overall, I think it was a success. So I hope you enjoyed learning about NeuroSymbolic AI. It is pretty complex, but it's a novel approach that I think has its benefits by easily incorporating rules in neural networks, which is something that's clearly lacking with the recent language models such as ChatGPT. Although our model here is really simple, I think it could be expanded to something more complex. Of course, it also has its downsides because it's really hard to gather training data that also follows all the rules you defined in your program. But maybe in the future NeuroSymbolic AI could play an important role in self-driving vehicles. So I hope you enjoyed the video. If you did, please consider subscribing, leave a comment down below, and I hopefully see you in the next video.